Hello friends, today our topic is HSRP for MLS1 and MLS2 switches. This is the topology we are going to configure now. In this topology, these two core switches are going to be the hot standby of each other. MLS1 will act as an active switch and MLS2 will act as a standby switch. Here we have four VLANs. VLAN 10 has a network 192.168.10.0/24. Similarly, VLAN 20 has a network of 192.168.20.0. VLAN 30 has a network of 192.168.30.0, and VLAN 40 has the network with 192.168.40.0. Here we have different VLANs on different switches in this topology. Here we have on switch 1 two VLANs, VLAN 10 and VLAN 20. Similarly, on switch 2 we have VLAN 30 and VLAN 40. On switch 3 we have VLAN 10 and VLAN 20. And similarly on switch 4 we have VLAN 30 and 40. First we will configure the VLANs on the access network switch. Access network is this switch. Access network is this portion of the topology where you can see that I have used layer 2 switches. Here I have used layer 3 switches for the core network. This core network is further connected with the router R1. So let's start our configuration. Here we have our switch 1, config terminal, host name, switch 1. We are going to configure all the four VLANs on it, as in case if this switch is working as standby switch, then these two VLANs will also be served by this switch. So the path for these two VLANs to access the MLS1 will be this one, from this switch to this and then to the core switch. So we have to create all four VLANs on this switch, but we will allocate the ports to VLAN 10 and VLAN 20 on this switch. So let's start now. VLAN 10, and 20, VLAN 30, VLAN 40. We will allocate port 1 to the VLAN 10 user and port to the VLAN 20 user. Interface path Ethernet 0/1, switch port mode access, switch port access VLAN 10. Similarly, interface path Ethernet 0/2, switch port mode access, switch port access VLAN 20. Now we have two trunk ports with this switch. Gig 0/1 is connected with the access network with the core switch, and gig 0/2 is connected with this access network switch. So as both for these two trunk ports we have to make them dynamic desirable, because by default all the trunk ports on the access network and core network switches are acting as a dynamic auto. Interface range gigabit 0/1 to 2, switch port mode dynamic desirable. Will assign IP addresses 192.168.10.10, 192.168.10.100 will be the default gateway for this user. 192.168.20.10, 192.168.20.100. Okay, now we will configure this switch for VLAN 30 and 40. Config switch 4, hostname SW4, VLAN 10, VLAN 20, VLAN 30, VLAN 40. Interface fast Ethernet 0/1, switch port mode access, switch port access VLAN 30. Interface fast Ethernet 0/2, interface fast Ethernet 0/2, switch port mode access, switch port access VLAN 40. Interface as this port is by default acting as a acting auto port, so so it means that a trunk link has already been established between these two switches. In order to establish a trunk link between these two switches, we have to convert one of the ports of these two switches to dynamic desirable. So let's change the uh, port, this port, to dynamic desirable. Let me check what is the port number. It's gig 0/1. Switch port mode dynamic desirable. Let's assign the IP addresses to the end users. 192.168.30.10, 192.168.30.100, 192.168.40.10. Now we will configure this switch for VLAN 30 and 40. Switch number 2. Config terminal, host name switch 2. We will create VLANs here, VLAN 10, VLAN 20, VLAN 30, VLAN 40. Interface fast Ethernet 0/1, switch port mode access, switch port access VLAN 30. Interface fast Ethernet 0/2, switch port mode access, switch port access VLAN 40. Interface range gigabit 0/1 to 2. Switch port mode dynamic desirable. Configuration of this switch is complete now. We will assign IP addresses 192.168.30.11, 192.168.30.100. 192.168.40.100. Now we will configure this switch. Config terminal, host name, switch 3, VLAN 10, VLAN 20, VLAN 30, VLAN 40. Interface fast incident 0/1, switch port mode access, switch port access, VLAN 10, switch port mode access, switch port access 20, interface gigabit 0/1, as this port is connected with the core switch and we want to establish a trunk link between these two switches. So at least one end of the trunk link should be a dynamic desirable and the other end should be auto, as by default all the ports are on auto mode, so we have to make this end a dynamic desirable. /1 switch port mode dynamic desirable. One nine two one six eight 10.11 10.100 192.168.20.11 20.100. Configuration of all the access network switches has been completed. Now we will configure our first core switch. We need to create SVIs on this switch for each VLAN. First we will create VLANs, VLAN 10, VLAN 20, VLAN 30, VLAN 40, interface VLAN 10. We will assign IP address to this interface. IP address 192.168.10.1. Here you can see, in fact you should note that I'm assigning an IP address 10.1, not 10.100, which we configured as a gateway of the end user of this VLAN. The gateway we configured on the end user of this VLAN will be configured as a virtual IP on both the switches. Now we will configure HSRP standby 1 IP 192.168.10.100. This is the virtual IP I'm going to configure on this switch for this VLAN, and this IP will be the gateway of all the end users of VLAN 10. Standby 1 preempt standby 1 priority 101. Now we will configure the SPI for VLAN 20. Interface VLAN 20, IP address 192.168.20.1, 255.255.255.0, standby 1 IP 192.168.20.100, standby 1 preempt, standby 1 priority 101. Interface VLAN 30, IP address 192.168.30.1, 255.255.255.0, standby 1 IP 192.168.30.100, standby 1 preempt, standby 1 priority 101. Interface VLAN 40, IP address 192.168.40.1, 255.255.255.0, standby 1 IP 192.168.40.100, standby 1 preempt, standby 1 priority 101. We have configured all the 4 VLANs and their HVIs. Now we will configure this trunk link between these two switches. One of the ends should be dynamic desirable. Interface gigabit 124, switch port mode dynamic desirable. Now I want this switch to be a root switch. So in order to make this switch a root switch, I have to configure, or in fact I have to configure it as a root switch. So for VLAN 1 we will configure it as a root switch, and in order to make it a root switch we have a command spanning tree VLAN 1 root primary, spanning tree VLAN 10 root primary, spanning tree VLAN 20 root primary, spanning tree VLAN 30 root primary, spanning tree VLAN 40 root primary. Now let's check show spanning tree VLAN 1. This bridge is the root bridge. So for VLAN 10 same status. For VLAN 20 this is the root. Similarly for VLAN 30 we have this bridge is the root bridge. 40. This bridge is the road bridge. Now, mm, something more on this switch. I have to configure this link as a routers link. Config terminal interface gigabit 1/0/21. Yes, it's 21th port. Okay. No switch port. IP address 10.2.2.1.55255.0. No shutdown. Okay. Now I want this switch to communicate with the router. So I have to enable routing feature on this switch as well. IP routing. Sorry, IP routing. Similarly, we will configure this switch as the standby of the MLS1. MLS2, VLAN 10, VLAN 20, VLAN 30, VLAN 40. Interface VLAN 10, IP address 192.168.10.2.255.255.255. You can see that we have given a separate SVI ID IP address on this switch. Standby 1 IP 192.168.10.100. This IP will be the same as we configured on MLS1. Standby 1 preempt. Standby, we don't need to configure the priority on this switch, as and by default priority is 100, which is less than 101. So it will automatically become the standby or backup switch of MLS1. Interface VLAN 20, IP address 192.168.20.2.255.255. Standby 1 IP 192.168.20.100. Standby 1 preempt exit. Interface VLAN 30, IP address 192.168.30.2.255.255.255.0. Standby 1 IP 192.168.30.100. Standby 1 preempt. Interface VLAN 40, IP address 192.168.40.2.255.255.255.0. Standby 1 IP 192.168.40.100. Standby 1 preempt. Interface gigabit 1/21. IP address No switch port IP address 192.10.1.1.1.255.255. No shutdown. Spanning tree VLAN 1 root secondary. Spanning tree VLAN 10 root secondary. Spanning tree VLAN 20 root secondary. Spanning tree VLAN 30 root secondary. Spanning tree VLAN 40 root secondary. Right. Now we will configure our last device, which is the router. No enable or configure terminal host R-1 interface gigabit 0/0 IP address 10.2.2.2.255.255.255.0. No shutdown. Interface gigabit 0/1 IP address 10.1.1.2 255.255.250. No shutdown. Let's configure a loopback interface on this router as well. Interface loopback 1 IP address 172.168.168.255.255.255.0. Now let's configure the IP routes on these three devices. Config terminal IP route 10.2.2.0 subnet mask, and next hop will be 10.1.1.2 IP route IP route 172.168.0.255. Done. Now it's done. Let's check the configuration now. successful, successful, successful. Now let's check the active switch. Show standby brief. Here you can see this switch is acting as a active switch, and its standby is 10.2. Virtual IP on this switch for each VLAN is this. What's the status of this switch? Show standby brief. We can see that its state is standby. Active switch right now is this, and virtual IP is this. So now try to ping our loopback interface on router. Ping 172.168.168.168. We have to add static routes, or in fact we have added static routes on switches, so we have to add static routes on the switch router as well. IP route 192.168. Let's add only one route, 255.0.0.10.1. Now let's check our pin. Yes, we can reach. IP route 192.168. This and this one. Okay, let's check how the status changes when we shut down all the ports of this switch. Terminal interface range gigabit 1 to 24. Shut down. see that now switch has taken his state back from standby to active. Now MLS 1 has MLS 2 has went back on his previous state to standby. Let's check again. Here we can see we have all the ports of MLS1 down. Now let's check how the transitions take place. You can see the ports have changed their states. Now it should receive the pings from this PC. Something's wrong here. This switch has taken over the charge now. It is working as an active switch, but still we are not getting any ping from the. Let me check. Ping 192.168.30.2. I am accessing this. Ping 192.168.20. Ping 192.168.20.11. Did I enable IP routing on this switch. Now let me check. Yes, got the ping. Actually, what was the issue? I didn't enable the IP routing on this switch. This switch was acting as a layer 2 switch. So I make the layer 3 feature available on this switch. Similarly, I think yes, I have configured IP routing on this switch. Sure, running config. IP routing done. Okay, now you have seen that this switch has changed its status from standby to active. Now let's ping dash d 192.168.10.11. Now you can see that we have lost the ping reply from this PC. Now let's check. Does it change its state, and how many ping breaks it takes to revert from standby to active mode. Yes, we have got our reply. State has been changed from standby to active. Trace route 192.168.168.168.168. Okay guys, this was our topology, and we configured the complete topology and all the configurations on all the switches. I hope you have understood the main idea of HSRP.